Hello everyone, so I am Mr. Chorsia from Perfect Academy, and as you all know, we are discussing basic concept chemistry, and we have already discussed about atomic mass, molecular mass, and molar mass also. And mole, mole is what? Mass divided by molar mass. Mole is mass divided by molar mass. Mole is mass divided by molar mass. Correct? And then we discussed concept of limiting reagent, and we have done some questions based on limiting reagent also. So today let's see some different kind of question, and let's see how will you do it. So a compound contains 3.2% of oxygen. Okay, a compound contains 3.2% of oxygen. Then what will be the minimum molecular weight of the complex? See, molecular weight or mass both are same only. Thing is, if you are saying molar mass, let's say molar mass you are saying. So mass for 1 mole, correct? So molecular weight is also same thing only. Mass of 1 molecule or weight of 1 molecule, correct or not? Thing is, how will you do this type of question? Tell me. 3.2% of oxygen in a compound, then what will be minimum molecular weight? Or they may ask in this way also. 3.2% of nitrogen, then what will be minimum molecular weight of the compound? Tell me, if there is 1 molecule, don't you think there will be at least 1 oxygen atom? In one molecule, there will be at least 1 atom of oxygen. At least 1 atom of oxygen, correct? And for 1 atom of oxygen, what will be the mass? You know, atomic mass for oxygen is 16 AMU. 16 AMU. 16 AMU for 1 molecule. For 1 molecule. Correct? Now what they are saying, there are 3.2% of oxygen means what? Means 3.2 AMU out of 100 AMU. Correct? Or you can say, if you are taking here for 1 mole, then it will be 16 gram. So here also it will be 3.2 gram. It's all what you are taking here. If you are taking AMU, atomic mass unit, so here also will be atomic mass unit only. So out of 100 AMU, there are 3.2 AMU of oxygen, correct? So you have to do for 16 AMU. What will be this? Let's say it is X. Let's say it is X AMU, correct? For every question, let's say they're asking for nitrogen. Here is nitrogen, and you know for nitrogen it is 14 AMU. So 14 AMU. And you know it is given 3.2%. So 3.2 AMU out of 100 AMU. Why out of 100? Because percent means what? Per cent. Cent means what? 100. Okay. So per 100. So 100 AMU and 3.2 AMU is the oxygen. They're asking when will it become 16.2 AMU? Tell me. X. So cross multiplication you can do. Then what will happen if you do cross multiplication? See, 3.2 into X is equal to what? 1600. So X is what? X is equal to 1600 divided by 3.2. Correct? Now you know, okay, this is 10, and you know 16 into 2 is what? 32. So 1000 by 2. So it will be what? 500 AMU. So this is the mass. This is the mass of 1 molecule when 3.2% of oxygen is present. In the same way, they are asking for nitrogen. Simple, what you have to do. Here 14 AMU. Everything else will be same. Only thing is answer will be different now. So 500 AMU is the correct answer. So limiting reagent concept we have discussed, and all the questions also we have discussed. Now we will move towards concentration term. I told you this chapter we can divide in 2 parts. So first part was mole concept and second part was concentration terms. So today we will discuss concentration terms, okay? All concentration terms we will discuss. Let's say in a beaker there is some solvent and there is some solute also, and this is what? Solution, okay? Solution. There is some solute and there is some solvent. For sure there will be some concentration. See, some mass you will give, let's say 5 grams sugar in 5 gram sugar in 100 ml of water, you will get one solution, correct? You will get one solution, and thing is that gram, that mass you are saying 5 gram, no, and you can convert it into moles, and some volume is also there. So what they are saying, whatever the solute mass and whatever is this volume, so what they are saying is, it is what? So concentration term we can divide in two parts, okay? One is temperature independent part, temperature dependent first, temperature dependent, and second is temperature independent. See, basically whatever solution you are having, we have to define that concentration on the basis of this constant term, that is temperature dependent and temperature independent. Temperature independent, correct? Temperature independent. Now temperature dependent, you might have heard about molarity. See, what is the meaning of temperature dependent? Okay, let's say you're having one solution of sugar solution, okay? If you heat it, what will happen? If you give more temperature, what will happen? Volume will increase. That means whenever in any formula of concentration term, in any formula, if volume term is coming, that is temperature dependent. Why? Because volume term is there. If you increase temperature, what will happen? Volume will also increase. No, that means volume depends on temperature. So here, whenever there is volume term in any formula, that is temperature dependent. See, there are lots of questions based on this, okay? So temperature dependent, first is molarity, correct? Second is normality. Third is percentage weight by volume and percentage weight by volume solution, okay? What we are going to do, we are going to define this in terms of concentration. Solute is there, solvent is there, and overall we will say what? Solution, correct? So you can write the solution is nothing but solute plus solvent, correct? Solute plus solvent. Now percentage weight by volume, or sometimes you will see percentage volume by volume. See, here volume term is coming, here also volume term is there, that is temperature dependent concentration term, correct? Second, molality, correct? Molality, mole fraction, and third is, see, here we are saying percentage weight by volume, what we will take here? Percentage weight by weight. Now you can see here there is no volume term, that means percentage weight by weight concentration term is temperature independent. Molarity, if you see formula for that, I will discuss, okay? In molarity formula also volume term will not come. That simply means that here this is temperature independent. We will discuss some question based on this also, temperature dependent and temperature independent terms, okay? Now one more term is there, that is ppm, parts per million also. Here also, if it is like parts per million weight by volume, or you can say parts per million by weight, correct? See, parts per million, weight by volume by volume. Okay, this is like same only. So we will not discuss this. We will discuss these 6 terms. And if there is anything else needed, then we will discuss, okay? So first is molarity. Okay, remember, while defining any concentration term, what we have to do, see, you know, in any solution there will be solute, there will be solvent, correct? So while defining any concentration term, in any formula, let's say for any formula, what I am saying, general formula I am giving, okay? For any formula, in numerator side, always solute will come. I told you, for solution solute is there, solvent is there. In numerator always solute will come. In every formula, okay, always solute will come. In denominator always solution will come, except one formula, okay? Except one formula, that is molality. In the case of molality, here solvent will come, okay? Solvent will come. Are you getting my point or not? Here you can write or solvent, or solvent. In the case of molarity, if in every formula, in numerator you will see solute, in denominator you will see a solution, and solvent also you may see in the case of molarity. In the case of molarity, okay. Now, so this is the general formula, correct? This is the general formula. Let's define molarity. Molarity. What will be the formula for molarity? Okay, let's just write down this. Now we will discuss. First, we will discuss temperature dependent term, that is molarity. See, this video you pay attention, and all the questions based on this you will be able to do. Okay. So first is molarity. First is molarity. I told you in numerator always solute will come. So mole of solute divided by what? I told you, except molarity always solution will come. Mole of solute divided by volume of solution in liter. Okay. So thing is, generally after saying this formula, after some 1 or 2 weeks, you may forget. That's why I'm saying you have to remember that this is liter. This is liter. This is not ml. Okay, this is not milliliter. This is liter. So do not confuse yourself here. So mole of solute divided by volume of solution in liter. Okay. Now this is molarity. Second is what? Normality. Normality. See, if molarity formula is this: mole of solute divided by volume of solution in liter. Let's say instead of mole, they are giving mass. 5 grams sugar, I told, 5 grams sugar. So what is mole? 5 divided by 342. See what I am saying? Instead of mole, if mass is given, let's say mass is 5 gram of sugar. That means what is the mole? Mole is mass divided by this formula. You never forget, okay? Mass divided by molar mass. So what? 5 divided by 342 is the answer. So 5 divided by 342, and then what is the volume of solution in liter? Let's say 250 ml you are taking. So 250 ml means what? 0.25 liter, correct? 0.25 liter. So 0.25 also you can do. So this will be the what? Molarity, correct? This will be molarity. Now what is normality? Normality is molarity into n factor. Molarity into n factor. This is very important, okay? Normality is equal to molarity into n factor. And what is n factor? What is n factor? What is n factor? Tell me. N factor, let's say you are taking HCl. How many H plus ion you will get? Tell me. 1 H plus ion, correct? 1 H plus ion you will get from 1 molecule of HCl. So what is the n factor? 1. Or one more thing you can do. Number of ions, number of cations, or see total charge you have to see. Total charge. N factor is total charge over cation or anion, okay? At any one place, either cation or anion. You see the total charge, and that is n factor. Let's say, for example, for HCl, you can see H plus and Cl minus. So what is the total charge over cation? It is 1. So n factor is what? 1. H2SO4. You can see 2H plus. You can see this what? 2H plus SO4 2 minus. So 2 plus charge means what? N factor is 2. Or 2 minus charge means what? N factor is 2. Now take any other example. Let's say for example you are taking NaOH. Can we write this as Na plus and OH minus? If you write this as Na plus and OH minus, so you can see total charge over cation is 1. Total charge over anion is also 1. See, this will always be same. It is neutral molecule, no? So if 1 plus charge is there, so 1 minus charge will also be there. So n factor is 1 only. Okay, now compare this MgOH twice, and it is giving you Mg2 plus 2OH minus. Now you can see 2 plus charge, so n factor is what? 2. or n factor is, from here also you can see it is 2 only. No. So n factor is 2. And this is, see, if n factor I am saying 2, that means what? 2 hydrogen was there. That means replaceable hydrogen. Here 2 replaceable hydrogen, so 2 n factor. Here 2 replaceable OH minus, so 2 n factor. Correct? This is what? Replaceable hydrogen. Replaceable hydrogen. Replaceable hydrogen. So this is, you know, replaceable hydrogen thing is very important. Okay, this thing you do not forget. Okay, this thing you do not forget. Okay, now, okay, then tell me, if you have to use this formula now, let's say 0.1 molar H2SO4 is given. 0.1 molar H2SO4 solution is given. What is H2SO4? You know, it is sulfuric acid. 0.1 molar H2SO4 is given, and someone is asking what is the normality? What is the normality? What will be normality? So normality is molarity into n factor. I told molarity into n factor. What is n factor? It is 2. Molarity into n factor. Why 2? Because 2H plus you will get. SO4 2 minus you will get. So molarity into n factor. So 0.1 into what? 0.1 into 2. So it is 0.2 normal solution. Okay. Either you say 0.2 normal H2SO4 solution or you say 0.1 molar H2SO4 solution. Both are correct. Okay. 0.2 normal H2SO4 solution or 0.1 molar H2SO4 solution. Both are correct. Okay. Okay. Tell me then. Instead of this, if I write 0.1 molar MgOH twice, then so now also you can say Mg2 plus and 2OH minus. So 2 minus charge and 2 plus charge means what? Again 2 will only come. So 0.2 normal. But sometimes in the numericals you will see instead of giving molarity value. See, if capital M I am writing, capital M is molarity. If it's capital N I am writing, that is normality. So what will be, okay, instead of M, they may give you normality, N. So what will be molarity? So molarity is equal to normality divided by N factor. So many times I have seen students will be doing mistake. Instead of dividing, they will multiply because they will remember this formula only. What I am saying, you have to rearrange it first, okay? So normality is given, molarity is not given. So molarity is 0.1 divided by 2. So what is the answer now? 0.05 molar. Correct? So this is the answer. Now I told you number of replaceable hydrogen. Okay, number of replaceable hydrogen. Okay, for H2SO4 it is 2. For HCl it is 1. But now one exception you see. So molarity formula you can write mole of solute divided by volume of solution in liter. This thing you never forget first. Okay. And normality is molarity into N factor. Correct or not? Tell me. Molarity into N factor. Now what we will do, I will discuss one exception case. Although it is not exception, whatever I am saying is correct only. But thing is, like I am saying, here it is 2, so N factor is 2. But now you see some more example. Now tell me, 0.1 molar H3PO4 is given. 0.1 molar H3PO4 is given. Then how will you write in normal? In normality formula, or what will be the value of normality here? The second case is 0.1 molar H3PO3 is given. Okay, how will you do? Okay, what is the N factor here? So 3H plus and PO4 3 minus. So 3 N factor, correct? Correct. So 3 N factor into 0.1 molar value. So 0.1 normal, correct? Whenever you will multiply by N factor, you will get normality value. Okay. So this is the answer. But here, even now also you can see 3 no. So 3H plus you will get no. So now if you multiply 3 into 0.1, you will get what? 0.3 normal. But that is not correct. Here, if you write 3 into 0.1 normal, this is 3 into 0.1 normal writing is not correct. You know why? Because if you draw a structure of it, you will get to know P double bond O, OH and H. See, This H is attached with more electronegative element, and while this H, so this is acidic hydrogen. This is acidic hydrogen. This is acidic, and this is also acidic only. But thing is, this is not replaceable hydrogen. See, although here you can see 3 hydrogens there, but if you see the structure of it, you will see there is only 2 hydrogen, that is replaceable hydrogen. So only n factor is what? 2. So n factor will be 2. So what you have to write is 3, okay, 2 into 0.1 normal. So it is what? 0.2 normal. 0.2 normal. Now homework for you is what will be for 0.1 molar H3PO2. What will be normality value? What will be the value of normality? That's what you have to do, okay? That is what you have to do. Value of normality for 0.1 molar H3PO2 is your homework. This one is your correct. So this question you have to do. Now we will move on. Okay, we will discuss one question first based on molarity, and then we will move for this percentage weight by weight, percentage volume by volume, and what is the meaning of percentage weight by volume. All this thing we will discuss, and molarity also. Okay. Also, first you write molarity. Molarity. First you write molarity. See, we have discussed molarity, normality, but we haven't discussed any question that we will do. So first, let's discuss molarity. Molarity. I told you whatever will come in numerator will be solute. So mole of solute divided by what? Mole of solute divided by, see, I told you this is the only exception case, okay? This is the only exception case. Okay, so in next class, so this is the only exception case. Mass of solvent in, I told you in the case of molarity it was volume of solution. Volume of solution. Only this is the case when solvent will come. This is mass of solvent. That was liter, here it will come kilogram. Correct? So molarity is mole of solute divided by mass of solvent in kg. So question based on this also we will discuss, okay? So mole of solute divided by mass of solvent in kg. If you compare this formula with molarity formula, what you will see here, molarity formula, molarity is mole of solute divided by volume of solution. Volume of solution in liter. I told you, you have to remember that this is liter, okay? And this is kilogram. Do not forget this. So these two formula is very important, correct? Okay, now let's say molarity is given, volume is given. Can you calculate mole? See, in every numerical, your aim is to calculate mole only. I have discussed. Mole is what? Mole is mass divided by molar mass. So from here, mole you can calculate. This is first formula. This is first. Second, I told you mole you can calculate at STP. See, okay, mole you can calculate given volume divided by molar volume. Molar volume. It is like same. See, here mass, here volume, here molar mass, here molar volume. No, at STP you can say at STP for any gas. For any gas, you can say this. This is the second formula from where you can calculate mole, and this one is third formula. This one is third. Mole, to calculate mole, what you have to do? Molarity into volume of solution in liter. This is third, and fourth is so 1, 2, and 3, and this one is fourth. So molarity is mole of solute divided by mass of solvent in kg. Molarity is mole of solute divided by volume of solution in liter. Correct? Now, okay. Now what we will do? Fourth is one more formula is. I told you. Okay. One more thing. Tell me. Is there any volume term? Is there any volume term here in this formula? No, because here mass is written. Here mole is written. That means it is what? This one is. So that means this is temperature. What? Dependent or independent? See, here there is no volume term, that is temperature independent. Independent. Here what will happen? You can see volume term is there, so it is what? temperature dependent, correct? Now what we will do, percentage weight by volume, what is the meaning of this? And then percentage weight by weight also we'll discuss, and percentage weight volume by volume, what is the meaning of this? See, all these things are very simple, okay? I told you in numerator always solute will come, in denominator always solution will come, except molarity case where solvent will come, okay, in denominator. Now, so weight by volume means what? Gram of solute, okay, mass of weight, no, weight, what is meaning of this? Mass of solute divided by, what is this? Volume of solution, correct? Mass of solute divided by volume of solution. And what should be volume of solution? It should be 100 ml. Why? Because here we are taking percent. I told you it is percent, means per 100 ml. Here also same thing only. Percentage weight by weight means what? Mass of solute divided by mass of solution. What will be mass of solution? See, I told you volume of solution will be 100 ml. Why? Because percent per 100. So here also per 100. So what will be this? 100 gram. There will be something in gram. Okay, in gram. In the same way, for this also you can write. So volume of solute divided by volume of solution. What will be volume of solution? Volume of solution will be 100 ml, and volume of solute will also be in ml only. So these are the formula that you should know. And so in next class we will discuss all the questions based on these formula, okay? And then some next formula also we will discuss. Okay, thank you.